In this video, I'd like to talk about the math question of the day for March 23rd, 2023. And with this problem, we need to evaluate the derivative of this function, or in other words, we are finding the rate of change of this function. And to answer a question like this, you do need to understand calculus, specifically differential calculus, dealing with derivatives. And you will need to know how to find the derivative of logarithms, specifically natural logarithms, and of composite functions, since we have a function within a function. This function 2x is within this outer function, the natural log. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And if you do have suggestions for future questions of the day, feel free to leave those as comments. And like I mentioned, to answer a question like this, to find its derivative, the derivative of this function, we are looking for the rate that this function is changing, since that's what the derivative actually measures. It measures the rate of change of some function. And to do that, we need to understand how to find the derivative of the natural log and how to find the derivative of a composite function, a function within a function. And also, we need to know what the rate of change is of a constant. Now, let's start with the natural log. Let's say we have some function g of x, that's the natural log of x. And if we look at the derivative, which we can write as g prime of x, or we could say the dg over dx, that's the derivative of the function g with respect to x. Either way, when we take the derivative of the natural log function, it is just 1 over x. And with this information, we can also use the chain rule to evaluate this function within a function. But let's think about what the chain rule is generally first. Let's say we have h of f of x, some composite function, a function within a bigger function. And when taking the derivative of a function like this, we first take the derivative of the outer function, h prime, but we leave the inner function as it is, and then we multiply by the derivative of the inner function. So we can apply this to the natural log of 2x here. And like I mentioned, we also need to know what the derivative of a constant is. So let's say that we have some other function, we can call it k of x, and we'll just say this is equal to some constant, which we can call c. When we find the derivative of a constant, when we look at the rate of change of a number that is always the same value, that derivative is equal to 0. And that's because constants don't change. If the derivative is the rate of change and we have a constant, we know then that the derivative must be 0 because, like I said, constants do not change. Their rate of change is 0 because they will always remain that fixed value. So now, looking at our function here, this f of x, let's first start by just rewriting it. We have that f of x is the natural log of 2x plus 6, and we'll take its derivative. Now, we know this is a composite function, so when taking its derivative, we take the derivative of the outer function, which is the natural log, and that is 1 divided by x in this case. But now, since we have 2x, that 2x will just go on the bottom. So we get 1 over 2x here. Again, that's the derivative of the outer function, this natural log function. Then we multiply it by the derivative of the inner function, and the derivative of 2x is just 2. Since here we can just use the power rule. We have x to the first power. We bring the 1 down and multiply it by the coefficient. 1 times 2 is 2. Then we subtract this exponent by 1. We get x to the 0, but anything to the 0 power is 1. So we have 2 times 1, which of course is just 2. Then we take the derivative of our constant, and we know that the rate of change of a constant is just 0. And I should mention that when you have a sum and you need to take the derivative of a sum when we're adding here, we just take the derivative of each term in the sum and then add them all together. So to finish this off, we have that the derivative of this function, the natural log of 2x, is just 1 over 2x multiplied by 2. So we get 2 over 2x, and then we're adding 0 to that. But the 2's cancel, so that we just get 1 over x. So this right here will be our final answer.